All right, here we go. Chapter 4, finally. Chapter 3 is forever. All right, so we're going to talk about polynomials. We've talked about polynomials before. We've talked about functions before. A lot of this beginning stuff is just kind of preparation for doing these things. A lot of it's just vocabulary, how to write stuff and all that kind of thing. So what's a polynomial, basically? Even if you had a number, oops, I got to change this. I always forget that every time. Even if you just had a constant, just a number, technically that would be considered a polynomial. All right, polynomials usually have variables with it, but I could write this with a variable and it still be equal to 3. How could I write this with a variable with it and it still be equal to 3? X what? Is 3x the same as 3? No, 3x what? How about to the 0? All right, 3x squared would be 3x squared. It wouldn't be 3, right? But if I had 3x to the 0, would you agree? So that's a polynomial. So just the number 3 is considered a polynomial. Like 5x would be a polynomial. If you had 3x squared y to the 5th. Now, these all just have one term. So specifically, it would be a monomial. Did I go over this with you guys at all? I remember teaching this recently. It might be Algebra 2, because we repeat a lot of the same concepts in Algebra 2 as we do in here. I can't remember. But anyway, those would be monomials. What would be a binomial? I'm just making one up here. 2x squared plus 3, I don't know, x y to the 5th. This would be a binomial. Why is this a binomial and this is a monomial? Mono meaning one, correct? And you got the nomial thing in here, right? So it's one polynomial, one term, okay, one term polynomial. This would be a two-term polynomial. Two-term polynomial. So we call this a what? A binomial. What makes this a binomial and not that? What do you think? The plus sign, exactly right, okay? So that plus sign. So anything, so if you got pluses or minuses, it could be a minus as well, okay? You could have that. What if I had this? 7x to the 5th. Why? There's nothing special about these numbers and letters. All right, I just picked this. This isn't even in the book. I just did it. So what kind of polynomial? Poly meaning what? What does poly mean? What is it? Multiple or many, okay? Multiple. Many is what I usually say when you see the prefix poly. So that's one, that's bi. This is trinomial. Very good. All right, because there's 3 terms, okay? 3 terms. Put the S on the end of that. All right, so that's a trinomial. That's one term, that's another term, and that's another term. Everybody okay with that? All right, let's talk about the degree. I think we've talked about that in here, didn't we? Talked about the degree of the polynomial. So what's the degree of this polynomial right there? You always look for the highest exponent. So at first it was a 3. You're like, well, Mr. Hammer, doesn't have an exponent. But then people might think, oh, that's 3 to the first. So it's a first degree polynomial. It's not. What is it? This is 3x to the what? 0. So that would be a 0 degree polynomial. What degree would this be? It'd be a 1, right? X to the first. That'd be a 1 degree or first degree polynomial. What about this one right there? There's a bunch of exponents, right? This is 3 to the first, x to the second, y to the 5th. Which one do we use, Abby? 5. Okay, so it's 5th degree polynomial because it's the highest exponent. If you're looking at this, I pause because I'm not 100% sure. I'm pretty sure, not 100% sure, but I think what you do is you look to see. This doesn't matter because it's not going to be on a quiz or a test or anything like that, but just for general knowledge. For some reason, I'm debating whether this is a 5th degree or an 8th degree. Why would I say an 8th degree? Because this has a 5 and a 3. So I'm leaning towards this as an 8th degree polynomial. It could possibly be a 5th degree polynomial. I'm not sure. It doesn't really matter that much, to tell you the truth. Remember, we did the degree thing, though. Remember, the degree of the one was higher than the one below, right? It was y equals 0, or it was whatever, that all that stuff. So we have talked about it, but I don't know. I should have looked it up. Even when I took my notes, I wasn't 100% sure. I put down the 8th degree polynomial, but I'm not really sure. It doesn't matter. All right, let's talk about one other word. This, again, like I said, the beginning of this is all vocab. It's just knowing some words. What about the coefficient? Coefficient. Might as well use these same. Might as well use these same things I've already written down here. And let's talk more specifically about the leading coefficient. All right, so I don't know. Let's just do this one right here. What's the leading coefficient of 5x? It's just 5, right? Okay, that's the number that's in front of the variables. Okay, that's the coefficient. All right, so just know what these words mean. Okay, just so we're speaking the same language. So that's the leading coefficient. What's the leading coefficient of that? It's 3, and so on. Okay, right here you look for the highest degree term. And what is the leading coefficient of that? This would be the highest degree term. What's the leading coefficient? It would be 7, and so forth. Easy, correct? Yep. All right. Since the name of this is called polynomial functions, we have a way. This is not new. This is just review, I guess. We have a way to write a polynomial function. Remember, we kind of are getting away from y equals stuff. What do we replace that with? Especially with function, right, f of x. So again, this is not new. We've been doing this quite a bit all year. So f of x, I'm just making this up, 3x squared minus 2x plus 3. That would be a polynomial function. This is a polynomial, and it's a function because you got that f of x in front of it. All right, so whenever you see that, that's considered a polynomial function. All right, here's something that's a little bit new. Let's talk about the zeros. Is the plural of zeros es or just s? I think it's s, isn't it? Zeros, yep, of a function. I don't know, for some reason, it just got in my head that it might be an e in there, but I wrote down just os, so I guess it's that. So the zeros of a function. It's basically this, watch. If I was to graph, let's just graph. If I asked you what the zero is for, let's just say a straight line, okay? The zero of the function is where it hits the x-axis. Everybody with me on that? So here's the x-axis. Where does it hit the x-axis? Well, it hits right there. So whatever point that is, right? I didn't really specify it, but whatever point that is, that's the zero of the function. Everybody got that? All right, your graph doesn't necessarily have to look like that. It could look like this. So how many zeros to this function? Are you asking me or telling me? You're asking. That's what it sounds like. How many? Why 2? That's right. It's where it hits the x-axis, okay? How many places does this hit the x-axis? Hits right here, and it hits right there. So how many zeros do we have for this? We have 2, okay? Everybody okay with that? I don't know, what if you had something that goes like this, and something goes like that? How many zeros to that? Just 1, because it only hits the x-axis at one place. What about this? What if I had, right, we've graphed stuff like that before, haven't we? How many zeros to this function? There's none. There are no zeros to this function. All right, we're going to talk about that a little bit later and what that means, but you could have all those different situations, okay? All right, now let's do something for real. Let's do some math. Yes. All right, so here's the first example. They're going to ask you a few questions about it. All right. Again, just so we're speaking the same language. So here's what they give you. They give you this function, this polynomial function, right? Because you're going to have a polynomial right here. They're just going to ask you some basic questions about it. Tell you what, while I'm thinking about it, let's go back to that last thing. Okay, so let's say I had this. Let's say that's at -2 and that's at +2. Okay, so when I talk about the zeros of a function, a lot of times we have to solve for x when we have functions. When we solve for x, that's what we're finding on the graph. Okay, we're finding out where it crosses the x-axis. All right, so where does it cross? You'd say x equals -2, and you'd also say what? Yeah, and x equals 2. All right, so those would be the zeros of the function. So if you wanted to find out where it crosses, that's where it would cross right there. Okay? So with that in mind, let's do this. So they ask you several questions here, three different questions. They say, state the degree of this polynomial. It's pretty easy. What's the degree of this polynomial? That's part A, the degree. What is the degree? Talk to me. What is the degree of this whole thing? 3, because you look for the highest exponent, okay? Highest exponent's right there. It's a 3, so what is it? It's a third degree, or you could say the degree is equal to 3. Okay, part B says, what is the leading coefficient? The leading coefficient. All right, so again, you look for the highest degree. Which one is the highest degree? The 3. What is the coefficient to that term of the polynomial? It's 1, right? So the leading coefficient is 1, all right? And then, well, that's actually part A and B. Doesn't matter, but that's A and B. They ask you 2 questions. Now it says, this is part B, it says determine whether 4 is, I'll put this, I'll put is 4 a 0 of the function. So what you're going to do, here's your function right here. Let's rewrite it. Okay, so if you looked here, what does the y equal at these points? 0. Good. Okay, the y is equal to 0 here. So what I'm trying to do is, I want to see, here's my function, all right? It's x cubed, so it kind of goes like this and like this, all right? But I want to find, is 4 a 0 of the function? All right, does that make sense? So does it cross the x-axis at 4? That's what we're looking for. All right. So what do I do? This is f of x equals. All right. So I want to see, does this whole thing equal 0 when what? X is 4. So what am I going to do? Just substitute, right? Just go 4 what? Cubed minus 6 times 4 squared plus 10 times 4 minus 8. It's pretty simple, right? Just plug it in for x. And let's see if it comes out to 0, right? Because it says, is 4 a 0 of the function? So with that being x, does the y, or the f of x, equal 0? Okay? You with me? So is x equal to a 0 of this function? Yes. Is x equal -2 a 0 of this function? Yes. Why? Because it makes the function equal to 0. It makes y 0. Okay? So let's see if it does. Well, this is 64. I already did the math for you, so you don't have to pull out the calculator. 16 times 6, that's 96. That's 40. That's minus 8. And this all comes out, just believe me, this comes out to be 0. So it does work. So putting a 4 in for this makes the function equal to 0. So we say that 4 is a 0 of the function, okay? It makes the function equal to 0. So a 4 makes that function equal to 0. So whatever makes that function equal to 0, that's what one of our zeros is, all right? Because they're going to use that phrase quite a bit. So 4 is a 0 of that function. Now, that 4 made that thing equal to 0, correct? We also call that 4 a root of the equation. Again, a lot of vocab on this first part of this lesson. It's a root of the function. So we're going to do some things. We're actually going to solve for x, okay? So instead of saying solve for x, they're going to say, what is the root of the function? It means the same thing, all right? It just means find out what x is. Find out the x that makes that function a 0. We call that the root of the function. It's kind of interchangeable. So when I say find the 0 of the function or find the root of the function, I'm asking for the same exact thing. It's just two different ways to say it. Everybody got that? You might want to jot that down somewhere. Okay, so the root of the function or the 0 of the function, it basically is asking the same thing. All right, let's jump into something a little different. We're going to talk, I don't think we've talked about it in here yet. Hopefully you talked about this in Algebra 2, imaginary numbers. Did you do that in Algebra 2? Yes? No? I'm not getting much response. I don't know whether you did or not. Is there a nod? Yes? No? I'm getting a little bit. Imaginary numbers, do you remember it? Or you just don't remember?
I remember it's like I.
It's I, correct. All right, yeah, and I'll put a little I right there. That indicates an imaginary number. So what is an imaginary number? Do you remember what it is? I equals, anybody remember what it equals? It is. It's exactly that. Yep. So you do remember. So I is equal to the square root of negative 1. I had a whole class in college called complex analysis. And it was all about, the whole entire course. It was kind of like you did calculus, but you did it with all imaginary numbers and not real numbers. The whole course was that. So there's a lot to learn about this. We're just barely scratching the surface on it. So if I is equal to the square root of negative 1, that's a definition, okay? That's something that we just know is true. And you're like, well, it's kind of unfortunate they use the word imaginary because we think imaginary is something that's made up that doesn't exist. This actually does exist. The problem is it doesn't exist on our number line. When we do that x and y axis, an imaginary number does not exist on a number line, okay? It's not a real number. So we got basically two types of numbers. We got real numbers. That's everything on the x and y axis, right, on the coordinate plane. And then we got these things called imaginary numbers, all right? So let's just talk about that a little bit. So what if I did this? What if I took I and I squared it? What's that equal to? Look at it and think about it. What's that? It's negative 1. That's right, because look, this is I, correct? But if I squared it, what happens to that square and that square root? Cancel each other out. So what's that equal to? Just negative 1. So it's kind of weird when I take an imaginary number and I square it, I actually get a real number. This is a real number that exists on a number line, okay? So they kind of are interchangeable, and we're going to talk about that in a second. Let's do a few more of these. These are kind of fun. So watch. What about I cubed? Well, you remember what I squared is, right? What's I squared? It's negative 1, okay? What's I cubed, though? It's I squared times I. Agreed? Or I to the first? Yeah? Well, let's look. What's I squared? What's I squared? Come on. Let's look up here and think. What's I squared? Come on, it's right there. It's in front of you. Somebody talk to me. I need to know you're awake. It's negative 1. Okay, right. So I squared is negative 1, correct. Okay, and then this is just an I, so what is it? It's negative 1I. But we don't write it negative 1i. What is a nicer, more compact way to write it? Just negative I. Okay? Do you see that? You're going to be working with these things from now and then. So I cubed is equal to negative I. So let's just write these down. I is equal to the square root of negative 1. I squared is equal to what? Just negative 1. I cubed is equal to negative I. What do you think the next one we're going to do is? I to the fourth. Let's see that. What's I to the fourth? Look at it and think about it and try it. It's I squared times I squared. Good. So it's I squared times I squared. Well, what is I squared? Negative 1. So it's negative 1 times what? Negative 1. What is negative 1 times negative 1? It's positive 1. So add that to my list. I to the fourth is what? I'm sorry, not negative 1. It's just 1, positive 1. And the cool thing about this is, if I keep going, this is just a cycle that just keeps on going back. So what's I to the fifth? I to the fifth is the same as I to the fourth times I. What's I to the fourth? 1 times I is I. So I to the fifth is 1. Or I. 1I. You with me on that? And then it just keeps repeating that pattern. So what's I to the sixth going to be? Same thing as I to the second, right? Just negative 1. Basically, we just take an I to the fourth out of it, right? If I take an I to the fourth out of it, because that's a 1, what am I left with? I squared. I squared is negative 1. What about I to the seventh? Take an I to the fourth out of that. What am I left with? I'm left with I cubed, and I cubed is negative I. Good. Okay? One more. I to the eighth. Well, take a I to the fourth out of that. And why can I just take an I to the fourth out of it? Because it's a what? It's a 1, right? So I take an I to the fourth out of it. I'm left with I to the fourth, which is a 1. And I could keep going and going and going. It's a circle, right, that just keeps repeating itself. So you could do this. I don't think they do this in here, but I had a book that did a bunch of these. What if I had I to the 17th? What's that equal to? What if I asked you to simplify I to the 17th? Now remember, every one of these I took out of I to the fourth. So every multiple of I to the fourth is a what? Like I to the fourth, I to the eighth, I to the 12th, I to the 16th. What are every one of those? It's a 1. Okay, so think of this. What could I take out of that's a multiple of 4? Well, higher than that. 16. So what is I to the 17th? I to the 16th times what? I to the first. Okay, I to the 16th is just what? It's a 1, so it reduces to what? I. So I to the 17th is the same exact thing as just I. You never did that before?
No, we never did that.
Okay. That's something that in my other books I've taught a lot. So anyway, there you go. I don't think this did that, but all right, I'll keep an eye on the clock here. I went a little far with that, got carried away. But now, remember I said what did I say about that one thing being complex, or not complex, one thing being a real number and an imaginary number? And I said they kind of go together. Well, that's called a complex number. I don't know if you've done this before. It seems like this is something you would do in Algebra 2. All right? And here's how I'm going to write it. A complex number is a combination between a real number and an imaginary number. Do you guys remember any of that? Okay. So this right here is which one? Is that the real or the imaginary? Yeah, that's the real one because it doesn't have an I with it. All right? This one right here, that whole entire thing right there, is a what? Imaginary number. So when you add or subtract them together, we have a thing called a complex number. That's why that course that I was telling you about, that's why it's called complex analysis. Why is it complex? Just because it's really hard? No, there's a lot of classes that are really hard, but they don't have complex in it. It's complex because you're dealing with complex what? Numbers. And so the combination between a real and an imaginary is considered to be a complex number. All right? There's a couple things in here I'm going to skip for the sake of time. All right? So I'm going to go right to example 3. So we've talked about roots, we've talked about degrees, we've talked about polynomials, and we've talked about i's. And so here's what we're going to do. I'll tell you what, let's do this. I think we got time. This is a little warm-up to example 3. All right? I'm just making this up off the top of my head. If I had x squared, let me think of something. 5. Okay. Two. Yeah, that'll work. Okay. I'm not very good at making these up off the top of my head, but I picked something that's fairly easy. We really haven't talked about this in this class. I think maybe once or twice, and I think you guys freaked out a little bit about it. I think it was this class. I don't know if it was this or Algebra 2. But what if I asked you to solve for x here? Do you have any idea of what to do? In my Algebra 2 class, we're actually taking a quiz tomorrow on this stuff. Do you remember how to factor? Remember that word, don't you? You can't go through Algebra 2 and not know the word factor. Okay, so how do I factor that? Remember this? Nobody? All right, that's why I wanted to do this, okay? So look, this is kind of like backwards FOIL method. You know FOIL method, right? First, outside, inside, last? Okay. This is kind of like backwards that. So this one times this one, the first two terms have to multiply to be what? X squared. So what do you think they are? X and X. Good. Now, this number right here and this number right here have to multiply to be what? Negative 10. Because first, outside, inside, last. The last terms, if I multiply them together, is going to be my last term here. Right? So this number times this number have to be what? Negative 10. What about the outside and inside? The outside and inside have to add up to be the middle number, okay, that middle term, negative 3x. So what you have to do, you got to think in your head. You got to do some multiplication. This is why it's good to know your multiplication tables. Let's do a little multiplication in our head to figure out.
Interruption. Tomorrow we have a $2 drop down day for sports team relationship. It's going to be Super Bowl themed, so you can either wear Eagles colors or Chiefs colors. The money will be collected by seniors around first period tomorrow.
Okay, so I got to figure out, listen, I got to figure out what times what equals negative 10, and those same exact two numbers add up to be negative 3. 5 and 2. Does it matter which one's positive, which one's negative? Am I going to make them both positive? One's positive and one's negative, because when I multiply it, I got to get a negative, correct? So I have to have a positive and a negative. So 5 and 2. Where do I put the 5? Where do I put the 2? Or does it matter? Does it? Do those add up to negative 3? Right. The 5's got to be the negative. Now, I could just change that, make it negative if I wanted to. Let's just do that. Is that all right? And then make that positive. Now, does that work? It does, doesn't it? Everybody see it? Okay, so negative 10, and when I add them up, it's negative 3. So let's do the FOIL method on it, just to make sure you understand why. Remember first, outside, inside, last? Did you do this stuff when you first learned how to do this? Yeah. So what's the first? It's x squared. What's the outside? It's plus 2x. What's the inside? It's negative 5x. What's the last? It's negative 10. Add those up. It's x squared, what? Minus 3x minus 10. So are these parentheses right here multiplied together equal to what we started with? Yes, they are. Okay? All right. I got to go back in time and teach this stuff because I don't think you got this stuff down. They're kind of working under the assumption in this book that you already know how to do this stuff. All right? So I'm trying to help you out a little bit and go back a little. Now, let's do another thing. I didn't just ask you to factor it, I asked you to solve for x. What if I had this? Everybody look up here. What if I had a times b equals 0? This could represent any two numbers, correct? Any two numbers that multiply together and your answer is 0. Tell me something about either one of these numbers or both of the numbers. One of them's got to be 0. Agreed? So if you have two things that are multiplied together and your answer is 0, one of those has to be a 0. Okay? So I could say what? A could be 0 or what? Or B could be 0. Or both of them could be 0. Does that fit right here? Look what I got. I got two things that are being multiplied together. Everybody watching? Okay. So I got two things that are being multiplied together and my answer is 0. So what must be true about either x minus 5 or the x plus 2? Either one of those has to be what? Equal to 0. It doesn't mean x has to be 0. It means what? X minus 5 could be 0, or what else? X plus 2 could be 0. I'm getting somewhere with this, so hang on. Now let's solve for x. We're ready to solve for x, because I told you at the beginning, I should have written it down, but at the beginning it said solve for x, find out what x is equal to. And we're ready to do it. What's x equal to here? It's equal to 5. Add a 5 to both sides, right? Subtract a 2. So x is equal to what? Negative 2. So there's my answers right there. Both of those are answers. Those are my zeros of the function, right? Because this is equal to 0. Do you see that? So this is one of my zeros to the function. Or they're my roots. Remember, zeros and roots I can use interchangeably. All right? You with me on that? Okay. What if? I'm getting somewhere with this, I promise. Okay? We're not at the example yet, but we're going to get there in a second. If they quit announcing things.
The bottom coding, please.
All right, so watch. What if I just told you the roots or the zeros, however you want to say it? What if I said x was 5 and x is negative 2? And I asked you to write a polynomial equation, okay, with these roots. Well, kind of. Not just set, I mean, you can't set 5 equal to 0, right? And you can't set negative 2 equal to 0 because negative 2 does not equal 0. 5 doesn't equal 0. But you're on the right track. So here's what we're going to do. Everybody watching? Because we're going to do this in the example. Okay, I just picked a super easy one. Believe me, this was a super easy one compared to what we're going to do here in a second. All right? So if you look at this, what did we have? We had x minus 5, didn't we? And we had an x plus 2. So what I'm going to do is I'm going to write two sets of parentheses equals 0. That's my polynomial equation. And what am I going to put in here and to get an equation, a quadratic equation? What am I going to put? Well, I'm going to put x and x. What's this going to be? Is it going to be a 5 to get that thing we started with? What did I say it was? What was in that parentheses?
Oh, minus?
Yes.
I thought you pointed to the end of the sentence.
No, like right here. But it's got to be either plus or minus, right? So it's going to be a 5. But what's inside of here? It's a minus 5. Even though it says x equals 5, we put minus 5 in here. What's this going to be? It's a minus what? Negative 2. Everybody see that? That's the only way for this to work. So if this is x minus 5 minus negative is a plus, this is x plus 2. And then if I FOIL it, let's FOIL it. X squared. Outside is plus 2x, inside is minus 5x. You add them together, you get minus 3x. The last is negative 10. equals 0. So what we did is we basically started with the answer. We started with the roots, okay, or the zeros. And then we came up with an equation that this is an answer to. I think I explained that pretty well. You hear what I just said? We came up with an answer, or we came up with the question that this is the answer to, right? And that's what they're asking in this problem. They're saying, here's the answer. You come up with the question. And how did you do that? You put two parentheses next to each other. You put x minus, then you stuck those numbers in, 5, -2, right? And so that right here is your polynomial equation. So you start with the roots, and they ask for the equation. We good? All right, now let's do a real example. That was an Algebra 2 example. Now let's do a pre-calc example. This time, they're going to give you, here's the roots, and they use the word roots here, okay? They give you, the roots are 2, 4i, and -4i. And what you have to do is you got to come up with a polynomial equation, right? Which means some polynomial equal to 0. And this is going to be the answer to that equation. So what do you think we're going to do? I'll give you a head start. Okay, so that's what we're going to do first. All right, so what times what times what? So what do I get put in here? Here's my roots. Whoops. There we go. So what do I do with that? We did it for the last one. What did I do? X. Come on, look at the last one. You got it right in front of you, right? You wrote it down. What did I do? I put x minus. Remember that? Okay, that was the whole reason for doing that. You didn't forget already, did you? So what am I going to do here? X minus. I'm going to do that for all of these. And then I'm going to put those roots in for it. Okay? So what are you going to put here? 2. What are you going to put here? 4i. What are you going to put here? -4i. Which, what happens here then? Yeah, this turns to plus. I'll just make it a nice pretty plus instead of marking them both. So that's how we started off. Not hard to start off like that, is it? You put your parentheses, you put x minus, whatever, how many times, how many roots they give you, and then you multiply them all together, you set them equal to 0. But that's not a polynomial function yet, is it? Equation or whatever I call it. What do I got to do with all three of those? What did I do with these two? I multiplied them, right? I took this one and this one, multiplied them, and I got this, correct? But I only had 2 things to multiply. Now I got what? Now I got 3 things to multiply. So what I would do is this. I would multiply those together. Once you get an answer for that, then do what? Multiply it by the x minus 2. Okay? So I'm going to keep that x minus 2 there. I don't want to forget about it. Let's see what I get here. I'm just going to put it in one big parentheses. So let's FOIL this. You ready? First outside, inside, last. So what do I get for the first? X squared. What do I get for the outside? And we'll do each step together, okay, so I don't confuse you. So here's the outside, the x and the what? The 4i. So multiply those together. What is that? Plus 4ix, or a lot of times we'll keep the I on the end. Is that all right? You can put 4ix if you wanted to. You can put the I in front of the 4 if you wanted to. All right? Just depends on the author and stuff like that. What about the middle one? Okay, the inside, right? Minus 4xi. What's going to happen there in the next step? Cancel out. Good. All right, and now what do we got? Negative times a positive is negative. 4 times 4 is, how about 16? 4 times 4 is 16. And then I got an I times I. What's that? I squared. And you know what I squared is going to be, don't you? We'll do that in the next step, though, okay? Is that all right? And all that stuff is equal to 0. Let's try to simplify that big parentheses first before we multiply it by the x minus 2. All right, let's see what we get. X squared. Are there any other x squareds I can add to that? Nope. What happens to this? 0. Now, let's think about this for a second. This is going to be a negative 16, but this is going to be a what? A negative 1. So really, what's this going to be? Positive, right. Positive 16 equals 0. Everybody see that? Because that I squared is a negative. Negative times negative is positive, 16. We're not done yet. I want to get just one big polynomial, okay? This is going to be an x cubed. I want it like x cubed, x squared, x, some number equals 0. That's what I'm trying to do. That's what they're asking you to do. Okay, it says write a polynomial equation, okay, with these roots. And we're almost there. We basically have one step to do. Just multiply those two things together. Another FOIL, right? So let's do it. First, what's that going to give us? X cubed, right? X to the first, x squared. Then outside is plus 16x. Inside, minus 2x squared. Last, minus 32 equals 0. I don't like it like this. Why don't I like it like this? Well, I got an x cubed. Look, what should go next? Yeah, let's put it in order, okay? They call it descending order, right? I think I talked about that in here before. Watch, we're almost done. X cubed, what? Minus 2x squared plus 16x minus 32, and that's equal to what? 0. Okay? Now, you're going to find, if you were to graph this, if you had Desmos and you got this out and graphed it, you're going to see that it's not necessarily going to cross, all three answers are not going to cross the x-axis. You're only going to get one answer that crosses the x-axis. Which one is that? The 2. All right? So if you graph it, look at it. I didn't graph it, but if you graph it, check it out and look at it. I still got one more to do. So we'll just finish this up tomorrow. I'm not going to assign anything tonight, okay? So I won't assign any homework tonight. I'll finish this up tomorrow. I only got one more example to do, and then I'll give you some homework then. All right.